Okay, today's lesson is 4.4, finding slope and rate of change, and your learning target is going to be able to find the slope and rate of change. So, at the top of your vocabulary, you have slope, and in parentheses, the letter M. We use M to represent slope in your equation. And then following that, we have three different ways to represent slope. So we have rise over run is the same thing as your change in your y over your change in your x. And that's the exact same thing as that formula, y2 minus y1 all over x2 minus x1. And we'll use those later on in the video. We have four different types of slope, and each of these pictures here illustrates that. So for example, in this first one, if your slope, that m, is larger than 0, so if it's a positive number, it's going to rise from the left to the right. So you're going to rise if that m value is less than 0. So it's a negative number. You're always reading these from left to right, so it's going to fall from the left to the right. So kind of think of like you're walking up a hill is your positives, or you're walking down a hill would be your negatives, m's. Whereas a line with the 0 slope, so if your m equals 0, it just means that you're walking straight across, kind of thinking about walking like straight across the ground. You're not moving up, you're not falling down. And then the very last one is called undefined. So, and again, my line was way off from the one that was illustrated there. But if you were, let's say, falling off a cliff, you have no slope to walk on. So I'm going to draw my little guy. And he's basically falling straight down. You have an undefined slope. So there is no slope. Those are your four different types. And in this next box here, it just shows the mathematical graph as far as what each of those represent. So here in red, this is representing that rise, as you can see here. In the blue, and I accidentally wrote over it. Let's see if I can erase that, and I can't. So I will put a box around, but that's your run. So use this image. Hopefully it won't be as marked up as the one I just messed up, but you're going to use that for your formula for slope. And so in this following example, in example 1, you have to tell whether the slope of a line is positive, negative, 0, or undefined. And then you're going to find the slope if it exists. So by just looking at it, and again, I'm going to zoom into them, and you can use those top 4 images on your note packet. Remember, always reading your graph from left to right, so kind of like a book. So if I'm reading from left to right, when I come across this, I'm going to be walking down my hill, so that is a negative slope. And then if I have to identify the slope, because it does exist, I'm going to use my rise and my run. So I'm going to pick 2 spots on this graph. And again, pick 2 that fall on a corner. So for example, again, I'm going to zoom into this. Oh man. You're going to pick 2 spots where that line crosses on a corner. So for example, I'm going to pick right here and right here. And I'm going to count my rise and my run. So if you think of like a sunrise, I'm going to count how far up or how far down I have to go.
Be careful, because each tick mark is represented with 2, not just 1.
Right, so we have to pay attention to these labels. So I'm going to count down 2. And when I count my run, it's how far do I have to go to the side. So again, pay attention to your labels. So we're actually counting by 2s again. So I'm going to go over 2 and 4. So I'm actually going over positive 4 units. So when I write my slope, the top number is my, top number is my rise, and the bottom number is my run. So my rise is -2, and my run is a +4. And you're going to always make sure you simplify those. So really it's a -1/2.
How did you know that the 4 was positive and not negative?
Because I went to the right positive 4 times. So think of it like your kindergarten number line. If you were going to run to the, pretend like the middle of there is 0. If you're running to the right, it's all positive numbers. If you run to the left, it's all negative numbers. Is that kind of how you do it, Miss Olson?
Yeah, that's how I explain it.
So my solution here is going to be a negative slope and a -1/2. I'm going to let Miss Olson explain this next one.
Oh man. Okay, so looking at this next one here, this is a little tricky to see, but I believe, which one's the axis and which one? I think this right here
I think that's the line.
is my line, right?
Yeah.
So if I look there at that line, if I use my cheat sheet here and kind of zoom out a little bit and go all the way back to the beginning, I knew it was a special one because if I wanted to put a person here, so Miss Zarnes drew this fabulous green person, they'd be falling off of a cliff, right? So I knew this was kind of a unique one. And if I fall off a cliff, I'm going to have an undefined slope.
Sorry,
and
I
this
took up
is-
so much space.
Yeah, I was going to say this might get a little, I maybe should have used a different color here, but it's going to be undefined, meaning we aren't sure, we are unable to really state much more than the slope is undefined. You'd have a person falling off of a cliff. This is different than if you look at number 3 here. Number 3, my line here is a horizontal line, and hopefully you remember from previous sections that I could actually represent that or write the equation as y equals -2, right? It's y, because it's why would you cross-country ski? You could put a little skier on here. And they're just going to go horizontal. It's not really very exciting, some might say, just going horizontally. So this slope isn't undefined. This slope is 0. So when you've got a horizontal or vertical line, make sure that you're paying attention. Your slope is either going to be undefined or 0. A little different than, say, number 1. And then quickly looking here at number 4, you can see you've got a line here. And it's not someone falling off a cliff. It's not someone cross-country skiing. So there is going to be a slope. The question is it a positive or a negative slope? And some of you might be thinking, well, the first one was negative, so this one must be positive. Well, you'd actually be wrong. As you read from left to right, this is going down, so it's going to have a negative slope. And then we have to figure out what that slope is. So like Ms. Zarnes did on that earlier problem, I'm going to pick 2 nice points there. So I think this point 0, 0. Oh, and maybe this down here.
Yeah, that's what I would pick.
So I am falling, and again, notice your scale here. So I'm going down 2, 4, 6, 8, 10. So I'm falling. So since I'm falling, I'm going down 10. And then I'm running, like Ms. Zarnes said, since I'm going to the right, it's a positive. And again, my scale is 2, so this is a positive 2. So slope, if you remember at the very top, slope is rise over run. Don't worry, we have a fantastic video we'll show you, so you'll always remember that. But your rise, I guess technically you're falling on this one, -10, and you're running 2. And just like Ms. Zarn said, we're simplifying this to -5. If you wrote -5 over 1, that's totally fine. But your slope for this fourth one is a negative slope, and your slope is -5.
Okay, on the next page here, examples 2 and 3, we'd like you to pause the video and then try these on your own and then resume so that you can check your work. So at this time, you're going to try examples 2 and 3. Okay, at this time, check your work. So example 2 should be a positive. So if you read that from left to right, you are walking uphill. For example 3, the first one is your slope equals 1. So make sure you reduce once you get that 3 over 3. And for example number 2, it is an undefined. And I'm just going to zoom in there so you can see my little pretty picture. So think of an undefined slope if you're falling off a cliff. So there's an undefined slope there. And then we're going to move on to example 4. If you needed to go back, feel free to pause the video and rewind and double check those. But we're going to move on to example 4 here, where you have to find the slope of a line that passes through the points. So here, if we don't have a graph, if you recall earlier, I had mentioned there's 3 different ways to find our slope. So we are actually going to use our slope formula. If we don't have a graph, we're going to use our slope formula. So I'm going to zoom into just example number 1. And our slope formula, again, we represent slope with m. So m equals, and if you call that formula is y2 minus y1 all over x2 minus x1. Those 1s and 2s are just representing your ordered pairs. So for example, in our ordered pair, we know that the first number is always your x. The second number, is your y. So again, this one, 3 is going to be our x, and 7 will be our y. The 1s and 2 are just representing first point, second point. So this is going to be point 1. This will be ordered pair 2. And all we have to do is plug those in. So we are going to write y2 is 7 minus y1 is 4 all over x2 is 3 minus x1, which is 0. And again, we're just simplifying this. So 7 minus 4 is 3. 3 minus 0 is 3. And you're always simplifying. So you want to simplify your slopes all the way down. So 3 divided by 3 is 1. So our slope is just 1. Okay, so for that second one there, we're going to use the exact same formula. So what I think would be a good idea is next to above it, why don't we write that formula? It is m equals y2 minus y1, wow, look at that y, x2 minus x1. So it's a good place to put our formula so we have something to refer back to. And then we're going to label our ordered pairs so at least remember which one is which. So it's going to be x1, y1, x2, y2. And I'm going to set up my work. So I have m equals y2 is that number. So we have y2 is 4 minus y1 is -2 all over x2 is 3 minus minus x1, which is also 3. And when we simplify this, we have 4 minus a -2. So you're thinking all the way back to chapter 2. So this really becomes 4 plus 2, which is 6. And 3 minus 3 is 0. Okay, now we have a 0 in the denominator. So think to yourself, can you divide 6 divided by 0? And I hope if you get stuck on this, use a calculator. You should get an error. If you do, This is an undefined slope. So if you think about the graph, when we have a vertical line, so I'm going to zoom out real quick and show you that graph we just went over in this one here. When you have a vertical line like that, your run, that bottom number, didn't move at all. You stayed in the same spot. That's what this slope is representing. So that's why we have an undefined slope. So what I'd like you to do is press pause, try that next one on your own, and then resume the video to check your work.
Okay, so here is our work for number 3. So make sure that you got the same slope and had the same work that we did. On the next, so here we are on our third and final page of notes. If you want to, I guess you don't need to zoom in, but just so you're aware, example 5, the directions say find the value of x or y so that the line passing through the 2 points has the given slope. These are definitely some harder problems, and they tend to take up a little bit of room, so make sure you kind of prepare for that. But the first thing that I think is important to do is write my slope equation. So I'm just going to write m equals y2 minus y1 over x2 minus x1. Make sure you're placing your y values on the top and not your x values. That's a very common mistake that we see. And then I'm just going to start labeling my points here. And I'm going to label my points above just so I have a little more room. So this is my x1, y1, x2, y2, and if you labeled your points differently, if you would have let this be x2, as long as you make that point y2, it doesn't matter. You are more than welcome to do that. I just think it's easier when I go through to label that first point as x1, y1, just because I kind of go in order. Now what I'm going to do is just start plugging in everything that I know. So here I know that m, or my slope, is 1/2. And so I'm actually going to put that in place of that m right there. So I'm going to write 1/2. I'm going to try and write small because I know this is probably going to take up a lot of space. My y2 is 7 minus my y1. It's a little weird, but it's just y over my x2, which is 2, minus 0. So now I have everything filled out, and maybe you recognize this. When we had two fractions set equally to each other early in the year, we cross-multiplied, and so that's what we are going to do again. So we're going to take the top of one side of our fraction times the bottom of the other, and then I recommend, or I kind of require in my class, to put parentheses around anything that you have two terms in. So I'm going to have 1 times 2 minus 0 equals 2 times 7 minus y. On the left side here, well, 2 minus 0 is just 2, and 2 times 1, that's 2 over here. And then, this is so fantastic, so much stuff is coming together here. Your distributive property from earlier in the year, you need to use that as well. Something a lot of students have a hard time with, or sometimes forget, is what is 2 times a negative 1y? Well, that is a negative 2y. And then we're looking for the value of y. So we want to get y by itself. So I'm going to subtract 14 from both. Because remember, my goal is to get this y right here, oops, by itself. So 2 minus 14 is a negative 12. The 14s cancel. Be careful. What is in front of that negative 2? A negative sign. So So I need to bring down negative 2y. Divide both sides by negative 2. Lately I've been seeing students dividing by negative 2y. Notice I'm just dividing by negative 2. You want the y to stay because you're trying to find out what y equals. So in this case, y equals 6. So what does that mean in the context of this problem? So that means going way back up here, that y value would be 6. So that ordered pair would really read as 6, 0. What I'd like you to do now is, hopefully you've got this all written down, and then look and try this second example on your own. So give example 2, or sorry, I guess it's the second part of example 5. Give this one a shot. One thing I do want to kind of give you a quick hint on this problem, because it is a little different than the last one. I would recommend writing your slope as 4 over 1. So now pause the video and see if you can do this one on your own. So here is our work for the second example. This is a little strange here, but we did end up getting y equals 6 for the second one, which was the same as what we had for the last example. So go ahead, double check. If you're finding that you're not getting the same answer that we are, please make sure that you are asking in class. Last thing that we're going to do, so here is our work for example 5. The last example we are going to do here today is example 6. So this is actually about my brother. He went to China, or is in China, and can use an internet cafe to communicate with me and our family. So the table below shows the cost of using a computer at an internet cafe for a given amount of time. And what we want to do is find the rate of change in the cost as a function of time. So a tip that Ms. Zarnes and I have for you is if, when you're writing equations or solving problems like this, when you see the word function, if you want to underline that, and whatever comes after that, so in this case time, that's going to be our x. So I'm just going to even label that with an x just so I remember. And then what comes before that, so our change in cost here, that is going to be our y. So when I look at my rate of change equation, which is change in y over change in x, I know for this problem, it's really going to be my change in cost, and maybe I should write this down here. I'm going to write it on the side here, but my change in cost over my change in time. And now, I don't know if Miss Zarnes taught you this or not, but sometimes it's a lot of work to write change. So if you want to use the symbol delta, you can. It's just a triangle. Sometimes I think it's fun. Just put a smiley face in there. That's not really mathematically what it should look like, but sometimes it just makes it a little more fun. So let's see here. What is my change in cost? So this is my down here. So what am I going up by each time? Well, from 7 to 14, I am adding 7. 14 to 21, I'm adding 7 again. So my change in cost is going to be 7. And that's going to go over, so this is referring to my rate of change. I'm just going to write m. That's the same thing as rate of change or slope here. And then my my denominator, I am adding 2 to go to 2 to 4, adding 2 to go from 2 to 6. So in this case, my rate of change is going to be 2 over 7. If you would like to, that is an improper fraction, write it as a mixed number. How many times does 2 go into 7? Well, that's 3, so 3.5. So that means for every hour, it's going to cost my brother $3.50 to call home or to use the internet cafe and communicate with us. So in this case, it is 3.5. I know some of you really like decimal, so yes, 3.5. So all of those would be fine. And that concludes the lesson for today. So make sure you've gotten all the notes written down. If you need to pause, go back, rewatch, feel free to do that, and bring any questions you have to class tomorrow. Okay, one more thing that Ms. Zarnes and I want to show you, or play for you rather, before you leave. You can listen and enjoy the music.
Slope, it's the rise over the rump. Distance up or down, divided by the distance side to side. Slope, it's the rise over the rump. Distance up or down, divided by the distance side to side. As the line moves from left to right, positive slopes go up, negative slopes go down. Y2 minus Y1 goes in the numerator. X2 minus X1 in the denominator. Slope, it's the rise over the rump. The distance up or down, divided by the distance side to side. Slope, it's the rise over the rump. The distance up or down, divided by the distance side to side. As the line moves from left to right, positive slopes go up, negative slopes go down. Y2 minus Y1 goes in the numerator. X2 minus X1 in the denominator. Slope, it's the rise over the rump. The distance up or down, divided by the distance side to side. Slope, it's the rise over the rump. The distance up or down, divided by the distance side to side. Slope, it's the rise over the rise over the rise over the run. It's the rise over the rise over the rise over the run. Slope, it's the rise over the rise over the rise over the run. It's the rise over the rise